This here is the binary button echo project. As you can see, there are 8 different button inputs, all with pull-up resistor configurations. These inputs are sent through the jumper wires into the Arduino, which is then in turn sent into this Moreland PCB, which has a 595 shift register and a 10 LED bar graph. When the buttons are pressed, this effectively echoes the button presses onto the bar graph. This is the code for the binary button echo project. In the first part of the code, all of the variables for all the pins on the Arduino are declared, including the pins for the Moreland bar graph and the input pins of the buttons. There is also a input total variable, which is used to add the binary values together, which will be used later in the program. In the setup function, all of the pins are declared for their specific use, including outputs for the pins that are used by the Moreland bar graph and inputs for the pins that are used by the button inputs. In the loop portion of the code, there are 8 different if statements, each corresponding to the button that they're assigned to. Each of these if statements reads the button, and if it is high, it will add the binary value of that button to the input total variable, which allows that input total to be read by the shift function and outputted onto the bar graph. The final part of the code is where the 595 shift register is used. First, the latch pin must be pulled low on the 595, which prevents the data from being outputted through the output pins on the 595. Next, the shift out function is used, which turns on the clock pin so that the bits are shifted out at the pulse of the clock, with the most significant bit first, and the input total effectively contains all these bits of data. Next, the latch pin is then pulled high to shift out the 8 bits through the 8 pins of the 595 shift register as one total byte, which is then effectively sent through to the bar graph. There is a delay of 10 milliseconds to confirm that the bits have been shifted out correctly, and then the input total is set back to 0 to reset for the next cycle of bits.